Assalamualaikum Prof. Today I will present my research proposal. The title is to characterize the chemical graph with its topological aspect of distant matrices. First, let me introduce. My name is Siti Hajah Fakihah binti Masyukri, metric number P5236. The table of contents we have introduction, literature review, methodology, Gantt chart, expected result, and reference. For the introduction, the topological index is a numerical value or a sequence for a given structure under discussions, which actually shows the physical, chemical, and biological properties of graphs. For the background of research, a topological index is a numerical graph invariant that is used to correlate the chemical structure of a molecule with its physicochemical properties and biological activities. Generally, topological indices are classified into 5 generations. First generation topological indices are integer numbers obtained by simple operation such as Wiener index, Hosaya index, and centric indices of Balaban. For the second generation, topological indices are real numbers based on integer graph properties such as molecular connectivity indices, Balaban J index, bond connectivity indices, and kappa shape indices. For third generation topological indices are real numbers based on local properties of the molecular graph such as information indices, the hyperwiener index, the Kirchhoff index, and electron topological state indices. For the fourth generation topological indices are the eccentric connectivity index, super-argumented eccentric connectivity index, and super-argumented eccentric connectivity topochemical indices, determetric-based agents, path eccentric distance. Some indices belong to the fifth generation topological indices. Fifth generation topological indices also are placed as new generation of topological indices. For problem statement, our focus will be on chemical graph, the graph whose vertex are the atoms and whose edge represent the corresponding covalent bond between the atoms. This branch of mathematical chemistry provides us the information about the chemical properties of chemical structure without using costly chemicals and labs. So, one can say that these are basically graph theoretic parameters that help us to predict and correlate the actual properties of the chemical structures. These are also very cheap and time-efficient methods to forecast and chemical properties of the chemical structure. Apart from the aforementioned usage and benefits of this project, it will also be useful to train a young lot of researchers and university graduates through such modern techniques so that they can be able to contribute to the development of the industry as well as the country. For research objective, this research has two distinct objectives as follows. First, to investigate the distant and adjacency matrices of chemical structures. Second, to investigate the classification of chemical compounds by calculating their energy, nullity, rank, and various spectrum-based topological invariant. For research question, first, can we determine the psychochemical properties of the chemical compound? Second, is it possible for us to examine the spectrum-based topological indices? Third, under what properties to construct programs in MATLAB? Fourth, can we characterize the rank, nullity, and various spectrums in this graph? For literature review, the first well-known usage of a topological descriptor in mathematical chemistry was by Harold Wiener when he was calculating the boiling points of paraffin. After that, to explain psychochemical properties, several topological indices have been introduced. Whenever a new topological invariant is introduced in mathematical chemistry, One of the most important questions to be answered is how this index determines the psychochemical properties of chemical compounds. Our main goal is to study two-dimensional topological descriptors whose numerical representation are still not studied. This study will help the researchers to understand the underlying topologies of these nanostructures. At the start of this project, we will review the existing literature. This literature review will help us to understand different techniques for finding different variants of degree-based, distance-based, and spectrum-based topological descriptors, and also help us construct computer algorithms. After this study, we will start our work of finding these topological indices for certain well-known topol to nanotubular materials. For the methodology, the overall methodology conducted throughout this study is as follows. First, we identify the structure of chemical structure. Second, we use ChemDraw to draw the molecule of the chemical structure and then transfer into HyperChem. For the third step, we construct a distance and the adjacency matrix of the graph by using topoclash. After this step, we separate our method into two methods to answer our objective. For the first objective, we use distance metric to generalize the data based on the distance metric and then find generalized equation. Lastly, we calculate the topological index. For the second objective, we use adjacency metric to find energy by using MATLAB, find the polynomial of degree 2 and the errors. Lastly, we calculate the initial index, nullity, and signature of chemical structure. This is our Gantt chart for the activity for semester 1 and 2. We collect all related research papers and identify the problem and method. Second, we identify the structure of a chemical structure. For the semester 2, 3, and 4, we do the some activities such as use ChemDraw and HyperChem to draw the molecule of the chemical structure, construct a distance and adjacency matrix of the graph by using topoclash, transfer the distance matrix in Excel and count the distance matrix, calculate the topological index, find energy by using MATLAB, calculate the initial index, nullity, and signature of the chemical structure. For the beginning of semester 3, we will start our thesis writing. For the expected result by doing this research, we expect that first, to characterize the distance and adjacency matrix of chemical structures. Second, to assess the classified chemical structure with respect to the nature of their energies by using MATLAB. Third, to investigate the classification of chemical compounds by calculating their nullity, rank, and initial base topological invariance. This is a few references that we use for our research. Thank you from me and have a nice day, Prof.